Hey everyone, I just got a question about linear regressions, and so I just wanted to cover this in a video. A random sample of 11 university students produced the following data where X is the minutes spent studying and Y is the exam score. The data are presented below. What is the value of the intercept of the regression line B rounded to one decimal place? Okay, so this particular student got this question incorrect, and so I just want to try and help everybody get questions like this right in Excel. Okay, so I copied the data into Excel. You'll see it's exactly the same as what is here. Okay, and so there's basically two ways of doing it. You can actually calculate the slope, the intercept, and the correlation coefficient in Excel just using some basic functions, right? So for the slope, you would do equals and then just start typing in slope and it pops right up. I use the tab button to finish filling everything in. Known y's, so you just want to grab the values, don't grab the actual data label. Comma, known x's, you grab those, scroll down. Again, don't get the data label, and we hit enter, and so now we see the slope. The intercept is going to be the same thing, equals intercept. It's the second one down here. Again, I'm going to type, hit tab to fill everything in. Known y's, again, I'm just going to grab the data and not the data labels. Close the parentheses, hit enter. There's the intercept. And then the correlation coefficient, again, I'm just going to start typing correlation. It pops right up. It says array, but it's still just this data and this data. And I'm going to close it out and hit, and it's 0.94. So this would be the equation. So our predicted y would be equal to the slope of 2.7 to one decimal place times x plus 16.4 rounded to one decimal place. If you're having trouble with the rounding, you can always right click on format cells and change the number of decimal places to 1. So you can see that, 2.4, I put 2.7. So I want to change that, 2.4. All right. And it is 16.4. So if we look back, it is telling us the correct answer is 16.4. So that's great. So that's one way of doing it. The other way of doing it would be to just grab the data and insert our recommended chart. And you should get a nice scatter plot. I would actually just prefer it without the line. So I'm going to select this one. So there's our scatter plot. I want to make it just a little bit smaller so it fits on the page a little better. There we go. All right. And now, once you've got your scatter plot there, you can actually right-click on any data point and add a trend line. And we're going to display the equation on the chart. So that's there at the bottom. It defaults to linear. So again, if you right-click on the data, you can add a trend line, and there it is. And now you can see the 2.4 and the 16.4 with the r squared value, which is just the correlation coefficient squared. Okay, so that is actually two ways of getting the line of best fit, either using the built-in functions or the graph. All right, if that helps you, that makes me happy.